All right, we're going to move on to the next parallelogram that was in our chart. And if you look at the next parallelogram was in our chart, scroll back here again, we fall into a rhombus. And a rhombus, since it is a parallelogram, these 1, 2, 3 that match with the parallelogram are already proven. So everything that's true about a parallelogram has to be true about a rhombus. And since it's a parallelogram, this one is the same. But a rhombus has 2 additional characteristics that we're going to have to prove. So this one has 2. We're going to prove the diagonals are perpendicular, and we're also going to prove the diagonals bisect the vertex angles. So we're going to be starting off with the known fact that we have a parallelogram, and we're going to break this down into, I'm just going to first of all prove the diagonals of a rhombus have to be perpendicular. So given that this is a rhombus, prove that they have right angles that are formed, because perpendicular is just another way of saying prove that there's 90-degree angles where they meet. So really our job is to prove right here at E that these will have to end up being right angles and they will be perpendicular. So what does the fact that it starts off as a rhombus help us with and help us identify? Well, the first things I'm going to grab here are the sides that are going to have to be equal because it's a rhombus. So because it's a rhombus, I know that all 4 sides are congruent, and I know for sure that the adjacent sides are congruent. So what I'm going to mark on my diagram is, because it's a rhombus, I know that AD and DC have to end up being the same. So AD has to be congruent to DC because all 4 sides of a rhombus are congruent. So sides of a rhombus are congruent. Next thing I'm going to be working on is this reflexive side, DE. I know that DE is congruent to DE by the reflexive property of equality. So I'm still trying to work on these angles sitting here at E and E. And what I probably should have done earlier is describe, or at least kind of plot out what I was thinking, that if I can get these 2 triangles to be congruent, the ones on the top, left and top right, then these would be corresponding parts of congruent triangles, those at E, which means then we could probably prove that it's going to be right angles because they form a straight line. And if they're equal and they form a straight line, then they must have be equal to 90. So right now, so far, I've gotten a side and a side, reflexive side, and now what I'm going to do is I'm going to use the fact that I know that a rhombus is a parallelogram, and because it's a parallelogram, when the diagonals meet, they bisect each other. So now I know that AE must be congruent to CE because the diagonals, I always do that with that, I need a DIA diagonals of a parallelogram bisect each other. And like I said, once you prove it, you can come back and use them in your proof. So we've got some properties of parallelograms that are coming in quite useful in the rest of our proofs. From here, what I got is a similarity statement between 2 triangles. So we know now that triangle ADE is congruent to triangle, and that's going to be CDE, by the side congruency. Try that one more time for congruency theorem. Now, because the triangles are congruent, we wanted to prove that the lines had, or that the angles had to be 90. So I'm going to identify this as angle 1. This is angle 2. Well, I know for sure that angle 1 has to be congruent to angle 2 because they are corresponding parts of congruent triangles, which forces them to be congruent. Now we're going to go back and use a little throwback that we had in lesson 1, or unit 1, and that is, we know that angle 1 plus angle 2 has to equal 180 because of a linear pair postulate. What the linear pair postulate said is, if we have 2 angles that form a straight line, adjacent angles that form a straight line, they would have to add up to 180. So if angle 1, angle 2 equals 180, and I know that angle 1 is the same as angle 2, but I can replace this angle 2 with an angle 1, so I'll have an angle 1 plus another angle 1 equals 180. So I'm taking out this 2 and replacing it with the 1, and that's through our substitution property of equality. And if you have an angle 1 plus an angle 1, that is 2 of those angle 1s that equals 180. And that is more or less collecting your like terms. And then we're going to take and divide both sides by 2. If I divide by 2, that means angle 1 has to equal 9 degrees, and that is our division property of equality. So now I've forced angle 1 to be equal to angle 2, and since angle 1 is equal to angle 2, I now know that angle 2 is equal to 90, if we want, by substitution. And we really don't need it because we have also proven earlier in the year that if we have one right angle when two lines intersect, there are four right angles formed. So we've definitely conclusively proven that the diagonals are always going to be perpendicular to each other in a rhombus.